Hello, everybody. I'm a staff engineer at Wayfair on the GraphQL platform team. And so our mission is to solve enterprise GraphQL and make it easy for people to use. And so show of hands, how many of you were able to attend my teammate Suray's talk on schema contracts yesterday? Okay, that's a good number. And how about the router success panel earlier today with my teammate Samana? Okay, so those of you who did, you kind of have an idea of the types of problems that we solve at Wayfair on the GraphQL platform team. And I'm here to talk to you today about another one, which is how we solved collaboration within the graph by introducing ownership, strong ownership, into a distributed system. So we're going to keep things pretty simple, although I'm going to try to dig a little deep into the technical aspects of our solution. We're going to cover the problem that we were facing, the solution we came up with that we hoped would address it, and then the findings that we came away with after the fact. So we're going to dig right in and start with the problem. So to set the stage, Wayfair's graph just continues to grow. So we started 2023 with about 33 subgraphs, 130 queries, 180 entities, and we were seeing about 220 million requests per day. Which isn't that's not small by any means. There's many graphs that you all may be operating that could be a little smaller than that. But compared to today, we've just grown. So we're now at over 155 subgraphs. We have more than 610 queries in our graph. We have 780 entities and counting, and we're at about 1 billion requests per day. And so getting bigger, that's clearly the huge problem, right? No, of course not. Growth is fantastic. It's phenomenal. But the challenge is coordinating the work that goes on into that growth. So 155 subgraphs, that's almost one-to-one with teams contributing to the graph. It's over 100 teams actively making changes to our supergraph. 1 billion queries, that's dozens and dozens of client applications, all trying to consume the graph. And all that work has to be coordinated somehow. We have to get them to work together. That's a really big problem. That's the problem we need to solve. How do we manage a supergraph at scale? So we've identified 3 what we consider key aspects to managing a supergraph at scale. Coordination to prevent chaos, tracking changes to provide context, and discoverability to empower our users. Now, I think the best way to maybe describe why these are important is to look at what happens if you don't intentionally foster these behaviors in your graph. So what happens if we don't coordinate to prevent chaos? Well, conflicts arise. People just don't get along when everybody's doing their own thing. And duplicate schema starts to enter the graph. You've got 20 different image entities, and which one is the one you should be using? It's really hard to figure out. Naming convention, or naming collisions happen. Everybody wants to have a product. They want their own version of a product. Who gets to be the real product? I see a few heads nodding on these. If you don't track changes to provide context, you get unhealthy entity contributions. You got people just shoving stuff onto entities willy-nilly. Somebody might say, hey, I think the product should have a user attached to it. You'll have surprise use cases arise, which can cause scalability issues. And you get schema drift. It just kind of gets worse over time. And if you don't have discoverability to empower your users, client teams struggle. They struggle to consume your graph. And if they're struggling to consume your graph, you have limited adoption. They're just not going to use it. And all of these combined increase technical debt. And as we all know, sooner or later, that debt has to get paid. You have to pay it off. You have to fix the problems. Now, show of hands, how many of you have experienced at least one of these problems yourselves? Okay. And how many of you have experienced all of these problems in some way, shape, or form? Yeah. It's a very common problem. So let's take a moment to talk about what we did to try to move the needle on this problem, managing a supergraph at scale. What can we do to implement those 3 intentional parts that contribute to making it happen. Well, this isn't our first GraphQL API. We've actually had a few at Wayfair, and we tried different things that didn't work along the way to get to where we are today with our federated graph with a very healthy GraphQL ecosystem. So what we tried complete autonomy. We ignored what's necessary to foster a good, healthy graph, and we ran into every single one of those problems that I showed on the previous slide. That's how we know about them. Certainly, it can make teams move quickly, but all those problems still exist. So we also tried gated approval. Let's just lock it down. Everything has to get approved by this core group of people. Well, like in theory, that's great because it provides a high level of accountability, but it's a slow-moving queue. And oftentimes, they never had the context to actually provide truly valuable feedback, and therefore, it just became a longer, slower queue. And we tried automated checks. So let's have computers solve our problems for us. And there's value there. It can solve for a great many simple, stylistic, like naming convention kind of problems, but it doesn't have the nuance of what is good in the technical sense and what is good like for the graph. And even when we combined all these together, they didn't quite create the recipe for success that we needed. They didn't make up for each other's deficiencies. We were missing a key part, and that key part is collaboration. It's really about fostering communication, connecting with people, not just creating a process. We needed to get people working together to proactively address schema inconsistencies, to make informed decisions, and to build a shared understanding of our supergraph. Okay, so how did we do that? How did we build collaboration into the supergraph? Well, we identified two problems that we wanted to solve. So the first problem, who owns a subgraph? We wanted to create a strong ownership between a subgraph itself and the people behind it. And so how did we do this? Well, luckily, Apollo already supports a built-in solution, the contact directive. Now, it's not part of the Federation spec, but it is a custom directive that Apollo Studio recognizes. As its name implies, it's for capturing contact info for an owner of a subgraph within its schema. It's a directive you apply to a subgraph schema, and it captures that information. It carves out space to provide a name, URL, and description, and like description's pretty cool. You can plug in extra links, a little bit of markdown in there. And so like, for example, we require that the get repo link is included in the description of a subgraph, so you know where the repo lives. And we use that for something cool I'll talk about in a little bit. And once your schema gets published with this contact directive in it, it becomes visible through Apollo Studio. And that's the part that's built in. Apollo Studio recognizes it, and when you visit a subgraphs page in Studio, you can see that contact info right there. So client teams, other subgraph teams, they can go to Studio and figure out who to talk to. Really powerful. But that kind of brings us to problem number 2. Once we know who owns a subgraph, we kind of need to answer the question, which subgraphs own what within the supergraph? And that might seem like an obvious answer. Oh, it's whatever is in the subgraph schema, that's what they own. But that's not really how federation works. Federation is a distributed model of ownership. And the best way to kind of describe what that means is to show you an example. So I've got 2 subgraphs on the screen. On the left, I have a book subgraph, which has a book type that's implementing a printed media interface. And on the right, I've got a magazine subgraph that has a magazine type, and it's also implementing a printed media interface. Now, it's pretty obvious who owns the book type and who owns the magazine type. They're only one subgraph. But who owns the printed media interface? Who's responsible for how that interface evolves over time? I don't know. It's in 2 subgraphs. I can't tell. So we needed to solve that problem. So we looked at, the first approach we looked at was ownership via a database to record such information. So basically, you take every node in schema and you put in a database with what subgraph it came from. And there's a few pros to that. Recording ownership is as easy as just writing a row in a database. And transferring ownership between teams, because of course that's going to happen, it's as easy as updating the row. But there's some pretty significant cons to this solution. It creates two sources of truth. You've got a supergraph schema, which records the schema, and you've got a database that records ownership, and somehow you gotta combine the two some way, and drift can, of course, happen. And therefore, it requires a way to actually visualize that ownership because it's separate from the schema. And of course, you have the database dependency itself. So we weren't really happy with the pro-cons balance here, and so we looked at another option. We looked at custom directives. We thought, what if we could just decorate the schema with that ownership information? And that's a pretty powerful concept. So what you get out of that is a single source of truth. Your supergraph schema reflects the ownership. Ownership is visible within Apollo Studio if you compose it into the supergraph, so you kind of get the win there. You don't need another tool. And you don't have a database dependency. So, of course, if we can shed dependencies, everybody loves that. There are a few cons, though. Applying ownership within the schema is a little complicated to do. And transferring ownership is also pretty complicated. But, in this case, pros outweighed the cons, and we had a winner. So we had the idea, what did we actually build? Well, we spec'd out what we call the owner directive. I know, very clever name. We're very creative. Owner directive is a custom directive to define which subgraph owns what. Pretty obvious. And it's applied everywhere that you can apply directives, which is everywhere except directive definitions themselves. And we include it in the supergraph via the nifty compose directive so that it's within the supergraph schema. And so when I say it's applied to schema a subgraph owns, let's look at that. So in this example, I have a book subgraph that defines a book entity and its ISBN key field. Those are all owned by the book subgraph. And so they get the owner directive for book subgraph. Now, I also have an author subgraph. This extends the book entity to contribute an author, and it defines the author entity that backs that field. The book and the ISBN are not owned by the author subgraph. They don't get the directive. Everything else, it is owned by the author subgraph. It gets the owner directive. And so this is an example of how this plays out in subgraph schema itself. Now, when those subgraphs publish their schema, it's contributed to the supergraph thanks to that compose directive, and you get a complete registry of who owns everything within the graph. So, pretty cool. We had our spec. This is what we wanted to do. Now, how do we actually get people to do it? How do we assign ownership? How did we tackle that problem, the actual implementation? Well, it turns out that manual ownership is extremely messy, and I do not recommend it. The ideal scenario is that the first team to implement schema is the team that owns that schema. That subgraph is who owns that schema. But if you manually apply it, maybe nobody claims it, and it has no owner. Or maybe many people claim it, and now you have ownership discrepancies, people fighting over it. And those are next to impossible to truly resolve easily. You gotta really wrangle that in. So we went a different direction. We decided to automate it. And so, again, if you were at Suray's talk, he talked about it a little bit. We have a service that we use to publish schemas. Teams don't publish directly to Apollo Studio. Instead, they publish to our service where we do some really nifty stuff. One of those things we do is apply ownership. And so the first subgraph that introduces the schema is the owner. All schema is guaranteed an owner, and there's no risk of multiple owners. So we tackled it that way. So let's look at how that works. So to apply owner, first, when a schema lands on our service, we parse that schema and a copy of the supergraph schema to AST, or abstract syntax tree. It's an object representation of the document. Makes it much easier to crawl and compare. We then crawl the schema, visiting all the schema nodes the directive can be applied to, the same thing that the on aspect of the directive definition, same list. Then we apply the owner directive to everything except root types because they're inherently shared, query type, mutation type. But the query fields and the mutation fields, they do get owned. We don't apply it to schema extensions. The definition of the schema is what should define that ownership. We don't apply it to directive definition arguments because if you can't own a directive definition, you shouldn't own its arguments either. And we don't apply it to schema that, of course, is already owned. If it's already owned, that's the owner. So we don't change it. And so we have our spec, we have our implementation, we now have a supergraph full of ownership, which is super cool. What do we actually do with that? Once we have it, what do we do to move the needle on collaboration? Because yeah, now we can find people, but we want to do more. So what do we do? Well, we made our automated checks smarter. Now they target people who are best equipped to solve the problem. So things like naming conventions, missing descriptions, required fields, we complain at the people who own it. We don't complain at the people who may be referencing the thing that was named poorly. It's not their fault. We also ensure that those who can take action are asked to take it, and allowed to even take it. So, for example, deprecating something, only the owner gets to deprecate it. Or tagging something, only the owner should get to decide to include it in a new contract. We also implemented ownership approvals. So we used the contact directive info to automatically loop in schema owners for big decisions, such as contributing a new field to an entity, or when subgraphs introduce a new query that maybe returns another bit of schema that somebody else owns, or when subgraphs try to move schema from one subgraph to another via the override directive. Those are cases where the owner should be looped in. They should be part of the decision-making process around those things, at least for consultation, right? So let's look at an example of what ownership approval actually looks like. And it's we're going to walk through a little manually, but the heart of this is what our system really does behind the scenes. And so what we're going to do today is we're going to contribute, we're going to define some schema and add it to our supergraph to power average rating and the number of reviews for a product. We're going to start off with a product entity, very basic setup here. And we're going to contribute a product reviews type. This includes our average rating and our total count. You might need more for reviews over time, but for today, this is all we need. Then we're going to add the reviews field to the product type so that you can actually access it. Now, we've defined our schema. It's very simple. Does this schema need owner approval? So let's look at how we make that decision. Well, first, we're going to compare the subgraph to the supergraph just like our system would. On the left is the subgraph, on the right is the supergraph. First, we're going to see, does the product already exist? And yes, it does. The supergraph already includes the product entity. Therefore, we're getting our first indicator that maybe we need to get owner approval. Now we're going to look at owner of the product entity. Who owns it? Well, it says the product subgraph owns it, and we're contributing to the reviews subgraph, so here's our next indicator. Ownership approval might be required. Now, finally, let's see what's being changed. Is anything actually being changed? Well, yes. So supergraph only includes a SKU field, the key field for that product entity, whereas our reviews subgraph is contributing the brand spanking new reviews field. So we need owner approval. So to get that approval today, how it works is when a team creates a pull request, we do all the same stuff that we just looked at in a manual way, but we do it programmatically. And once we determine ownership approval is needed, we look up the subgraph's contact info, contact directive, and we grab that get repo link, and we look up the code owners and we loop them in. And so pipeline blocked, we add a comment on the pull request saying you need to go get approval from these people. Those people get looped in, conversations happen, and finally you get approval. Now your pipeline's unblocked, and you can merge it into the supergraph. You can actually publish that schema. And so this is like our super awesome system for getting those people looped in. So what did we learn along the way? Did this actually move the needle on the things that we were hoping it would affect? Well, let's take a look at that. So we found that ownership certainly helped. Looking back at our 3 key aspects of managing a supergraph at scale, coordination to prevent chaos, tracking changes to provide context, and discoverability to empower our users, we were able to move the needle on all of these. We were able to improve communication, to move the needle on coordination. We're also able to, this system also resulted in less duplicate schema because people were talking more together. We also are seeing fewer naming collisions because people have a better understanding of what's actually in the graph. As far as tracking changes go, entity contribution has higher visibility because teams are working together. New use cases are actively being discussed, so teams aren't surprised by what's appearing in the supergraph. And schema evolution is far more guided, but in a distributed way. And for discoverability, client teams know who to talk to, not just because of the contact directive, knowing how to actually get a hold of a team, but because they know who owns what within the graph itself. That ease of understanding has increased adoption. I mean, you saw how rapidly we're growing, and that's because people can understand the graph. And we're seeing less technical debt grow. So we were able to move the needle on all of these things. We also found that our process has overall improved. So we looked at those 3 things we tried, and aspects of them all still exist, but in a new, better way. We still have autonomy to propose changes to the graph and then contribute on ensuring that those changes are good. We still have our experts around, but they're no longer gatekeepers. Instead, they're available to pull up alongside teams to help them solve their biggest, toughest problems and empower them to move quickly. We still have automated checks, and you saw as we look, in the earlier slide, they just got smarter. And now we have collaborative feedback. So teams who should be involved in conversations are getting involved in conversations and helping to make meaningful change. But as always, there's room to improve. First, I talked about the fact that we block for ownership review at the PR phase, which is a little late in the game. We really wish it was happening earlier. And so Apollo has a fantastic schema proposals tool. And what we want to do is tap into that system to get those owner approvals happening as part of that schema proposal phase. So get it earlier when the conversation should be happening. We also think ownership reviews can expand to more use cases within the schema. So things like the requires directive, when teams are opting your subgraph into a new use case, there should be a conversation around that. And we also believe that client operations are another great use case for ownership, where you can answer questions like who owns the query or who owns the fragment, because those might be exported from a library and a whole other team is maintaining. And that visibility would certainly help. So before I close, I want to leave you with one more thought, and that's when should you start? And with most things, there's no time like the present. You should just start now. And it doesn't matter where you are on your graph journey, you should just start now. If you're brand new, just getting started within the supergraph and your GraphQL journey, well, you're setting the right foundation by taking steps to create collaboration and manage your graph now. It's going to help prevent future challenges that you're inevitably going to encounter because you're going to get people working together from the start. And it's going to empower your teams from the start because they'll have the tools to help them make more informed decisions and better decisions because of it. But if you're already well into your GraphQL journey, and when you raised your hands, I saw a lot of you are feeling the pain points that I talked about today. Well, it's not too late to get started now, because it's going to allow your teams to start collaborating more efficiently. It's going to improve the ongoing quality of your Supergraph schema. And therefore, it's going to help prevent a growing technical debt. Yeah, you're going to have stuff you may need to go back and fix, but that it's a lot better to have stuff to go fix than have an ever-growing queue of things to fix. And so I gave you a vision into how we step back and solve this problem. And you might come up with a different way. I hope, I inspired you to start thinking about this problem and start trying to solve this problem. And if you come up with a better way or a different way, please find me, let's talk about it, because I certainly want to hear about it. I love a good idea. So that's all I got today. Thank you very much.